Integrity. We are a nonpartisan think tank, and we're dedicated to improving the quality of governmental decision-making. We produce original scholarly research in the fields of economics, law, regulatory policy. We also advocate for reform before the courts and executive agencies. We have expanded quite a bit into the realm of state energy policy, and that's part of the reason we're partnering with EnerKnol today. Speaking on our behalf will be Dr. Untitled. She's the Energy Policy Director at the Institute for Policy Integrity, and she's been involved in proceedings in a number of states, including New York, California, and others. On EnerKnol's side is Jonathan Crawford. He's the head of research at EnerKnol, and he has been working in the electricity and energy industry for more than a decade. And Jonathan will actually get us started with a little bit of background and talk about some of the trends of energy storage.
Thank you, Ileana. Appreciate the introduction, and thanks to all of you out there for tuning in. I'm sure many of you guys are fighting the afternoon low after eating all that Halloween candy, so we're glad to have you join us today. Before I kick it off, just a little bit about EnerKnol. U.S. energy policy is complex, fractured, rapidly changing, and scattered across hundreds of agencies, and regulators, frankly, aren't in the business of making information easy to access or understand, so enter EnerKnol. We are basically conceived to change that by kind of streamlining and enhancing the search, tracking, discovery of energy policies across the North American energy sector. So when I talk about the platform, I'm talking about a central access point for policies across the full suite of federal, regional, and state energy agencies and legislatures. Our claim to fame is we boast the largest database for the North American energy sector. The platform is paired with our news feeds and original research to optimize the tracking of major decisions, policy trends, and compliance rules. The idea is we help to capitalize users to act on market impact and developments and eliminate blind spots. So after that, now that I had that shameless plug, we can dive in from there. So just a quick background. Many of you guys know the energy storage basics, but I'm going to kind of just set the table for those who may be less informed. So battery storage to some is affectionately known as the Swiss Army knife of energy for its multiple functions. In fact, the EIA identifies 11 distinct applications, and just about all of them revolve around balancing the grid, whether frequency, power demand, or maintaining an equilibrium in the event of a supply surplus or shortage. Over the last 2 decades, the most additions of battery storage, storage have been exclusively battery storage, according to the EIA. So for the purposes of today, when we talk about energy storage, we're really talking about battery storage, not so much pumped hydro, although pumped hydro definitely has a large capacity. There haven't been many additions, again, over the last couple of decades. So over 80% of U.S. large-scale battery storage is powered by lithium ion, and that technology is favored because of its high cycle efficiency for charging and discharging, its high energy density, and its fast response times. And not only can battery storage serve many functions, allowing it to earn multiple revenue streams, but it can be, and I think this sometimes gets lost, can be interconnected at various points throughout the system, and that's a huge advantage when you think of transmission constraints and the ability to site the power closer to where the demand is. Also of note is battery storage has shorter planning periods. On the downside, and I think this is kind of the central kind of lag for the technology, are its operational constraints around the limited discharge time. And then the kind of the issue we're going to tackle today is the regulatory front is starting to become more and more of a hindrance as the technology advances, it's coming up against, and there's more deployment, it's coming against kind of regulatory hurdles, or figuring more prominently. Next slide. So for all its diverse applications to date, much of the growth in battery storage has been concentrated around just a few applications. So about 90% of large-scale battery storage is for frequency regulation, and that's for helping the system balance the frequency to correct for unexpected mismatch in electricity supply and demand. In California, more than 60% of the storage capacity was installed in response to the Aliso Canyon natural gas facility. There was a leak there, and so it helped kind of maintain system reliability. And about another kind of thing is it's not just concentrated around these few policy drivers, it's also concentrated geographically. Almost half of the large-scale battery storage is in PJM, and that's owing to the frequency regulation market there. So next slide, please. So what we've seen is, again, at its initial onset, battery storage has been driven just by a few policy drivers. But as this kind of chart illustrates, states are really laying the foundation to spur growth through a much broader range of policy drivers. And it's not just utility scale battery projects, it's also residential. And as this slide shows, there's about 8, EnerKnol has identified about 8 buckets or categories where states have been looking to promote battery storage. So you can see there's quite a diversity of application and legislative proposals to promote energy storage through different kind of methods and means and leveraging it in different ways. Another thing to point out is there's a strong appetite among state lawmakers to establish procurement programs and to develop procurement targets. Equally interesting, I think, is there's a push by state lawmakers to study how to evaluate the benefits of battery storage, how to integrate batteries into the system and into the markets. And I think that last point brings up 2 interesting aspects. One is many states are still in the early stages of the learning curve of understanding how to handle battery storage. And I think that's a testament to how complex it can be, given that the technology doesn't fit neatly into one box. It serves load, it provides load, it also provides dispatch power supplies. I think another thing to point out is that it's also, there's a considerable disparity between states where they stand on integrating energy storage. So while some states are just trying to study the technology, other states like California are much more mature. In fact, as my colleagues will point out, they're starting to evaluate the environmental benefits and set criteria on the performance. So it was a banner year for energy storage if you look at the kind of legislative activity at the state level. States passed no fewer than 9 pieces of legislation to promote battery storage, and you'll see there's been over 80 proposals, and that I think it's probably safe to say we're at or near record legislative activity at the state level as the technology matures, as the costs fall. California, not surprisingly, led the way, and there's 3 measures to point out in California. One of the leaders in energy storage. They expanded the technology eligible to participate in the programs. They also extended the self-generation incentive program to 2026. Again, my colleagues at the Institute for way more on that. California also took steps to enable the commercialization of microgrids, and again, storage plays a key role in the systems. Another kind of noteworthy state, Colorado. Legislatures there passed rules for the procurement of energy storage systems by utilities. Colorado now finds itself one of 14 states requiring utilities to include storage in their IRPs. So not surprisingly, the states leading the way on energy storage, now strictly in terms of legislation, are either A, progressive, B, rich with renewable resources, and you see Hawaii and California there, or a combination of the two. There appears to be a bit of, as this slide indicates, there's a bit of one-upmanship among the states to see who can claim the mantle of being the leader on battery storage. Most recently, New Jersey set a target for the state to reach 600 megawatts by 2020 and 2,000 megawatts by 2030. Massachusetts is looking to go to 1,000 megawatt hours by 2025. So it's starting to add up. There's a lot of things in the works there. How big is the energy storage market going to get? Wood Mackenzie says in just 5 years, it'll reach over $4.5 billion. Quite mind-boggling. And as the graph shows, battery storage capacity will jump about tenfold. And importantly, I think, is growth is coming more and more from residential installations. In fact, over the first half of this year, between a third and a half of all deployments were residential. And you know, again, I think that's a testament to state-level activity. You've got states like Maryland where they pass tax credits, for example. So it's not going to be all smooth sailing, as Wood Mackenzie suggests that the sharp declines in technology are going to kind of slow down, as basically they attribute this to a combination of higher raw material prices and a tightness in supply. But Wood Mac suggests in their forecast that this could be temporary, and the declines in the technology costs will continue apace once the production capacity expands and the raw material prices fall again. So that concludes my portion of the webinar. And with that, I'm going to pass off the baton to Dr. Untitled, who will dive into the state programs. Thank you very much.
Thank you, Jonathan. Before moving on to discussing some of the state-specific policies, I'm going to spend some time to talk about the framework that here at Policy Integrity we use when we think about energy storage policies. As Ileana mentioned, Policy Integrity uses economics and law to support smart policies for the environment, public health, and consumers. So what makes an energy storage policy smart? Obviously, we want the policy to actually drive investment, and compensation mechanisms are one of the major drivers of investment. So what is a compensation mechanism, a smart compensation mechanism for energy storage? From an economics perspective, if a resource is bringing a certain value, it should obviously be compensated for that value. And if that resource is bringing multiple values, it should be compensated for all of those values. As Jonathan mentioned, energy storage is like a Swiss Army knife with multiple values and possibilities. But some of these values are currently not explicitly priced in markets, or they're not separately priced in markets. So that aspect might prevent energy storage from compensated for all the benefit that it brings to the grid. So if we can stack those values and ensure multiple revenue streams for these values, then it will be a smart policy and incentivize deployment. Another important aspect to compensation is whether or how much a state provides upfront incentives. While costs have been going down, as Jonathan mentioned, there are still high upfront costs to installations of battery storage. This is especially problematic if energy storage cannot access multiple revenue streams immediately. So if a policy has an upfront incentive scheme or a bridge incentives to accelerate deployment in the initial years, it will significantly increase market penetration. Another point regarding compensation is that incentives for behind-the-meter storage depends heavily on the rate design that the end users face in that particular state. For example, if a consumer has time of use or critical peak pricing, then relying on energy storage to avoid withdrawing electricity from the grid during the peak periods actually saves the customer money. So if there are demand charges, behind the meter energy storage can save customers some money. So these kind of rate designs also incentivize energy storage. A second determinant of whether a policy is smart and would drive efficient deployment is whether the policy or the regulation is creating barriers for some types of storage systems. Again, from an economics perspective, if an energy storage system has the technical ability to provide a service, it should be allowed in that market and should be able to get compensation. But there could be some explicit and intended, as well as some unintended barriers due to regulation. For example, some ISOs and RTOs have explicitly restricted what type of resource could provide what type of service. But others had certain rules which were designed with more traditional resources in mind, and so inadvertently hampering the incentives for storage. For example, if you have a system operator that has a performance penalty that will be imposed on a resource if it cannot perform during the entire emergency event, then that is problematic for battery storage. As Jonathan mentioned, one of the limitations of energy storage is that discharge duration is limited. So if it is a 4-hour battery, it can provide services and benefit to the grid for 4 hours, but if your critical events last 6, 7, 8 hours, then that energy storage system will be penalized. So that kind of policy inadvertently creates barriers. To overcome that, FERC recently issued Order 841 and directed ISOs and RTOs to revise their tariff rules so that storage can participate and provide all the services they're capable of providing, including energy, capacity, and ancillary services. Right now, ISOs and RTOs are working on those filings, and we're waiting to see how they're modifying their rules. At the state level, one of the most common barriers is whether standalone storage is eligible for the same incentives as paired storage. If not, there might be some unintended barriers for standalone storage systems that could still be very useful and valuable to the system. Finally, greenhouse gas consequences of energy storage is an important component of a smart energy storage policy. As Jonathan mentioned, many states are turning to energy storage to help achieve their climate goals and reduce emissions. However, there's academic literature that shows that storage can indeed increase emissions. So policies need to be designed with that goal in mind. Otherwise, the state might get adverse results and possibly face some backlash from stakeholders if emissions increase. Recent state analysis is showing that energy storage incentive programs might actually be increasing emissions. California, for example, recently issued a staff proposal to update its behind-the-meter incentive program because their analysis showed that it was increasing emissions. Obviously, from a regulatory risk perspective, it's much better that the policy can value environmental benefits from the get-go without the need for updating. So with this framework in mind, we're going to talk about some of the states and give more details about what is happening in these states. We're going to start with California. California was the first state in the country to develop an energy storage target. The initial target was set in 2014, and the initial target was 1,325 megawatts by 2020. At the time, there was a roadmap that was issued that laid out what each state entity can do. So ISO and California Public Utility Service Commission looked into what they can do to help maximize the value of energy storage and how they could work together. Since then, another 500 megawatts added with AB 2868. And this bill also directed the 3 largest electric corporations to invest and accelerate the widespread deployment of distributed energy resources. The state has a self-generation incentive program for behind-the-meter distributed energy resources, including energy storage. Earlier this year, the governor extended the program by about $166 million per year through 2023. And as I mentioned a little bit, the California PUC staff introduced a proposal to include greenhouse gas emission signal to ensure that these storage systems can reduce emissions. And in this updated proposal, the CPUC staff also proposed that 75% of the SGIP incentives is used for storage. So the comment period on that just ended, and the CPUC is expected to make a decision in early 2019. One other reason why California is on the forefront of energy storage policy is also they're very progressive about the cost-benefit analyses they're using. The tests they use for utility investments or resource planning purposes are from a societal cost perspective, and they include many social values, including greenhouse gas emissions and criteria air pollutants. So obviously that's beneficial for storage, because storage can indeed reduce emissions if the policies are designed correctly. The next state we're going to move to is New York, our home state. New York has a recent target of 1,500 megawatts by 2025. And currently, New York State Department of Public Service and NYSERDA is working together to create a comprehensive storage policy to reach state's goals. There are a variety of policy options considered in the roadmap. I'm just going to talk about a few of them. Essentially, New York aims to provide more accurate price signals to show not only the system-wide value of energy storage, but also the locational value of energy storage. Essentially, they want to incentivize more energy storage so that we can get rid of system peaks, very expensive system peak capacity, as well as deploying energy storage so that we can reduce some of the congestion at the local networks so that we can avoid the need for distribution upgrades at these congested locations. Some of the policies they're looking at are direct procurement actions, whether they're in the form of non-wires alternatives by utilities or state agencies themselves leading by example. Clean peak actions are trying to align incentives with other environmental regulations in the state. So they're trying to value the environmental benefit of energy storage, not just greenhouse gas emissions, but also for other pollutants like NOx regulations, since these can be reduced using energy storage as well. Essentially, the state wants to ensure that the incentives for energy storage are aligned with the environmental value of the state. Among other actions, coordinating between wholesale markets and the distribution system is very important, and it is a part of the storage roadmap in New York. As we discussed before, storage can provide value to wholesale markets and the distribution network at the same time. So a smart policy would allow dual participation into these two markets. And obviously that requires coordination between the Public Utility Commission and the system operator. So currently the Department of Public Service in New York and NYSERDA is working on how to make that happen. Next frontrunner is Massachusetts. Massachusetts was also one of the early adopters. As part of an energy storage initiative, they had this program, Advancing Commonwealth Energy Storage Program, that gave multi-million-dollar grants to many demonstration projects to look at feasibility and scalability of different energy storage programs. More recently, Bill H 4857 was enacted, and it set the target of 1,000 megawatt hours by 2025. This was part of a big, broader advanced clean energy bill. As part of the bill, the Department of Energy Resources is directed to consider several different policies to cost-effectively deploy energy storage. These include refining existing methods so that they could properly value energy storage. So there's definitely room for value stacking or multiple revenue streams. They're also looking into alternative methods such as energy portfolio standards, or even the use of energy efficiency funds if energy storage can be shown to provide sustainable reductions in the peak load. And perhaps one of the most cutting-edge consideration in Massachusetts is that the bill directs the department to look at the use of mobile energy storage for resilience. So this is very cutting edge, and the process is a bit slower. The department is directed to submit the recommendations by 2020, but it is definitely very exciting in terms of use of energy storage. Then we have up-and-comer states. New Jersey, our next door neighbor. They shifted gears as Phil Murphy took over Chris Christie this year. The renewable energy bill enacted in this year set very ambitious goals for the state. 600 megawatts by 2021 and 2,000 megawatts by 2030. Essentially, Phil Murphy wants to achieve 100% clean energy by 2050, and this year they're working on a master plan to figure out how to achieve that goal. As part of the renewable energy bill, the New Jersey Board of Public Utility is directed to submit an energy storage report with suggestions on how to meet the state's targets within a year. There are already some existing incentives in New Jersey, but these incentives but eligible projects integrated with either a new or existing New Jersey Class 1 renewable energy. 2018 budget was about 1.8 million. What is going to happen next year is going to depend on how the energy master plan is going to shake out. There's a new bill in the works that is opening the way for a value stack approach. And the bill directs the board to take into account all the different values and storage can provide. The bill is just introduced, so we don't know what will happen, but there's some smart language in the bill. Especially given that New Jersey's very ambitious clean energy goals and other mandates, such as the 3,500 megawatt of offshore wind, energy storage is definitely expected to play a big role in New Jersey. Another up-and-comer is Nevada. So Nevada, there's no mandate yet. SB 145 provides incentives for energy storage under the Solar Energy Systems Incentive Program. This program is intended to provide up to 5 million incentives for residential, commercial, industrial customers, and some large energy storage projects for hospitals, airports, public safety, and critical infrastructure facilities. And then there is another bill, SB 204. It directed public utilities customers, not necessarily theirs, consider whether it's beneficial for the state to establish a target. Bradel Group just completed that study, and they released the study within the last few weeks. They looked at a variety of benefits, including reduction in resource costs, avoided fuel costs, avoided distribution system costs, etc., and found that 175 megawatts of energy storage can be cost-effectively integrated by 2020. This number goes up to the range of 700 megawatts to 1,000 megawatts, depending on what happens to the battery, what happens to the storage costs. The comment period on that docket just ended, so hopefully we're going to see a final order soon. Finally, I'm going to talk about a couple of new processes that are happening in 2 states. In Texas, there were already some wholesale systems that existed, but there wasn't much action on the retail side. The PUC has been soliciting input to develop facts necessary to establish a regulatory framework within Texas's legal structure. Comment period on this docket ends tomorrow. So again, hopefully sometime soon, the commission would finalize their decision. There's a lot of potential for energy storage in Texas for use of energy storage. The state has a lot of intermittent wind, but also the state has a lot of creative retail rate designs that could be a boost to energy storage if and when these decisions are finalized. And last but not least, Colorado just passed energy storage procurement. It encourages the installation of energy storage in the state and integration into long-term programs. They have very similar language to New Jersey bill. There's a lot of good language that opens the way for value stacking and compensation for multiple values. So we will definitely be watching these two states. So to sum up, declining costs and increasing renewable and clean energy goals of the states are pushing states to explore policies to speed up storage deployment. They are broadening the array of policies from everything from resource planning to tax credits. So there are lots of policy options in various states. And definitely states are committed to procure more storage. Just the pledges in 2018 has reached over 7,300 megawatts by 2030. So it is definitely an exciting time to be in this space. With that, thank you for listening, and I'm going to turn it to Ileana to moderate.
Thank you so much, Burcin and Jonathan. That was really interesting, full of lots of great information. I think probably enough things that our very knowledgeable audience may not have known already or may not have thought about. So thank you for bringing all of that forward. The first question we have is for Burcin. So in looking to compensate energy storage for all of the values it may provide, are there concerns about double compensation? And if so, how could that be addressed? And Burcin, before you answer, I just want to remind everyone that you can submit Q&As in the chat function. Please send them to the organizer only. So Burcin, you can take it away.
Thank you, Ileana. That's a very good question. And when you think about the different values, so it is not that hard. I realize that it is not simple, but in New York, for example, for distributed energy resources, we have this mechanism that we call LMP plus D plus E, which compensates. The LMP shows the energy value, and there is another distribution value, capacity value component, and then the environmental value component. So when you think about that framework, it is easy to calculate the value of each component and what benefits that energy storage brings. And as long as you categorize your value stacks correctly, and your ISO and your Public Utility Service Commission can coordinate how to compensate and who gets to compensate and the energy, what component is compensated in what market, I think it is relatively easy. So if you know that your energy storage system is getting LMP at the wholesale level, then in this value stack framework, you will not ask your retail utilities to compensate the same system. So as long as there is a clear division of roles between your wholesale operator and your the Public Service Commission's jurisdiction, I think it is relatively easy.
Thank you, Burcin. And then a question for Jonathan. If you showed that slide of the storage sweeteners, and it went by year. There was years, and then there was all the different buckets, and it would be great to hear your thoughts on where there might be more activity in the coming years, based on the trends that you've seen.
Yeah, that's a great question. I would suspect that there'll be, as these markets, as these states kind of evolve their policies, as the technology becomes more mature, you'll see a greater demand for renewable integration. right now, it's been dominated by procurement targets, how to analyze the benefits for purposes of integrating, considering storage in IRPs. And there's also been, as I said before, a lot of studies to investigate how to integrate this. But yeah, as I said, you know, as renewables penetration ramps up, there's going to be the need for leveraging storage to kind of better harness those supplies, those intermittent supplies.
Thanks, Jonathan. This question might be for Bertrand, but Jonathan, you might also have insights from one of our listeners. Does energy storage, is energy storage under the jurisdiction of states, like capacity, or is it under jurisdiction or something else, or some combination?
So it is a combination. I mentioned FERC Order 845, 841, excuse me. So if a storage system can provide energy ancillary services or capacity value at the wholesale market, FERC directed ISOs and RTOs to allow the participation of that resource to ISOs and RTOs. So if energy storage systems want to provide energy capacity and ancillary services to a particular system operator, then that system will be subject to the jurisdiction, FERC's jurisdiction. At the same time, energy storage can be subject to state jurisdiction as well. Lots of distribution utilities are looking to use energy storage to help with their systems. Those are certainly going to be, those investments are definitely going to be subject to State Utility Commission jurisdiction. And then there is some open area for what happens when energy storage can participate both at the distribution level and the wholesale level. And I think that is going to shake down based on how states cooperate with their relative ISOs and RTOs.
Great. And then a quick follow-up on that is, do you have a sense of when FERC will publish an order on distributed aggregated storage, because it was in the NOPR but not in the order 841 that you just discussed?
I am eagerly waiting for that order as well. So unfortunately, I do not have any predictions on that.
Great. Jonathan, in terms of the storage being a Swiss Army knife, is there anything, we had somebody ask about thermal storage in buildings. Is there anything along those lines, any sort of like more passive storage, or is it really the, I think, 11 things that you set out at the beginning?
Yeah, there certainly could be more uses than specified. I didn't, there's some really interesting applications. In fact, I'm hearing that some peaker plants are actually using energy storage. So you're seeing very unique applications. You're also seeing electric vehicles. Actually, Con Edison is rolling out a very novel plan to electrify school buses that could then serve as a storage. During the summer when school's out of session, it can those school buses can double as storage for the purposes of peak shaving. So absolutely, there's novel uses.
Great, thank you. If anyone has any more questions, please feel free to type them into the chat box now. Otherwise, we will start wrapping up. I think that's it. Thank you guys so much for listening. Thank you very much, Bertrand and Jonathan. This was a really wonderful, informative webinar. Everyone who attended, and I think everyone who registered, will get a copy of today's slides, as well as a report that EnerKnol has compiled with some really good information. And if you have further questions, Bertrand and Jonathan's contact information is on the screen. Please feel free to email them. And yeah, thank you so much. Thank you, everyone.
Thank you, everyone, for tuning in.
Thank you.